Okay, okay. Alright, looks like it's gonna be Sudoku solver day. Yesterday was the checker to see if it's working, now it's the solver to see that it solves. I guess I did this before at some point. How I did it, I'm not sure. Alright, write a program to solve a Sudoku puzzle by filling out the empty cells. Like yesterday, it's going to be a 2D board of characters, digits, or dot for blank. Okay. Alright, so question is, what is the method to solving? So yesterday I assumed it'd be backtracking, kind of, where you fill out certain spots with certain values and then test. I wonder if that's going to work. I wonder if that's going to be the best way to work it, though. So 1, 2, 3. So with constraints yesterday, it was like using sets and then removing values from the sets. So row 1, column 1. Okay, let's go ahead and try the sets method again. So for each, let's say I'll do the row possibilities, and this will be sets of 1, 2, 3, 4, 5, 6, 7, 8, 9 for every row in range 9 rows. And then same thing for column and box possibilities, subbox, where this is subbox 0, subbox 1, subbox 2, 3, 4, 5. I guess, can I assume that this is a valid puzzle? Yeah, okay. It's guaranteed to have an insertion. Okay, so I'll go ahead and do the sign function, row, column, and value. And this one will be automatically setting the possibility to be a single value for that spot. So row possibility at the row is going to be, so I would normally remove the value from the set, but here it's just going to assign it to the set, so the set of that value. And then the column possibility for that column is going to be equal to that value. And then the box, let's say the actual box index is going to be row divided by 3 times 3 plus column divided by 3. So if it was like, say, row 4, column 4, or row 4, column 5, would be 4 divided by 3, which is 1. 1 times 3 is 3. So it's going to be in this 3, 4, 5, and then plus 1 to be in subbox 5, subbox 4. So then box possibility for this box index is going to just have this value. And I'll go through every row and column. In the board, if the board at this row column is a dot, then skip it. otherwise the value is going to be equal to offset is ordinal of 0. It'd be ordinal of the board, whatever character it is, minus the offset. So that'll convert it into an integer and then assign at this spot this value. And then let's go ahead and just print out, let's say, the box possibilities to verify. Box possibility is a 2D array. I need to do for every blank in range 9 box possibility. Oh wait, I think this works unless I made my 2D array incorrectly, or array of sets incorrectly. Yeah, that's incorrect. The row. What did I do wrong here? So yeah, this is totally wrong. What was I intending to do here? So assign a particular value. The assignment needs to remove it from the possibilities of that row, column, or box, actually. I see. It's not supposed to do this. It's supposed to remove. I was thinking of something else. I was thinking maybe, yeah, I was thinking something else. Oh, oops, let's remove. 1, 2, 3. Okay. So box possibilities remaining for the first subbox is 1, 2, 4, 7. Second one is 2, 3, 4, 6, 8. Everything besides 6. Everything besides 8, 4, 7. Okay, looks like it's right. Okay, so now that I have a bunch of possible values for each row, column, and subbox, what do I do? I guess I should be guessing and checking. So if I have this cell at row 0, column 2, subbox 0, I guess there's a certain number of values that can be there. Like let's say 1 can be there. That satisfies all the current possible constraints. Like 1 is still possible in the row, column, and subbox. So I try 1 there, and then I move on. I move on to the next cell and try something there. Huh. Or I can move on to the next row. No. Next cell is going to be the same row, different column. Fill out. If I go to the same row, different column, go step by step, testing, and then if it doesn't work, then go backwards and that's a lot of backtracking. I really need to look at what my previous solution is after this to see what the hell I did before. 5, 3, 6, 9, 8. So if I do backtrack, there's a lot of steps in the backtracking though. There's a lot of guesses. And then if I do backtracking, it probably needs to be lists instead of sets, I want to say. Lists instead of sets. Because you need to have an order with which you, I think you need to have an order with which you iterate through the possibilities for that thing. Do you? Maybe? So if you go through, assign some number here, could be 1, could be 2, could be 4, 1, 2, 4. I think those are the only ones that immediately come to mind. I wonder. In theory, if I linked up the position to the constraints that apply to that spot, like this spot needs to have a value that matches, that is from the stuff in the row possibilities, index 0, column possibility index 2, subbox possibility index 0. Like in theory, if this was like a human type problem, then there should be something, some position here that only has like one possibility. But like the harder Sudoku problems, there might be like multiple ones that have maybe 2 possibilities, and then you have to kind of guess and check. Guess and check. So for every position, if I link it to the row, column, and box possibilities that must obey, and only try a value that is in those sets. Only try a value that is in those sets. could also work the other way around and have a set of values that are possible for every cell. And remove them. See here. 5 for this row 5. 5 here. What did I do actually? Assigning 5 to this row and column. Remove 5 as a possibility from this row, from this column, and this subbox. Moved it from the possibilities from each. Okay, let's go ahead and do something like this. Let's see what it gives me if I actually go through each position and let's say create a set. Say to do to two. How do I find the union of sets here, or the intersection? What is the quickest way of doing it? Intersection of multiple sets. Set 1 intersection and then a comma delimited list of other sets, common. Okay. So it would be row possibilities for this row intersection with the column possibilities for this column and the box possibilities. Oh fuck. Box index is going to be so that's the box index for this box, and then I'll print out this row column and the possibilities. Zero, 0, 1, 2. Really? It should only be 5, no? For this position, huh? Why is it 1 and 2? I guess I should be skipping the ones that I know are already signed. I guess maybe 5 was... If 5 wasn't there, then the possibilities besides it. Okay. So let's go and skip things that are already there. If the value at this spot in the board is already filled, then continue. Okay. Alright, so the first okay. 0, 2, there's possibilities of 1, 2, 4, 0, 3, 2, 4, 2, 6, 8, 2, 4, 6. Okay. Reasonable. And there's even some that are only has one possibility, so I could possibly fill that out. Okay, guess that's a start. So if there's only one possibility, then I can update. Assuming it's kind of a solvable in the easy way without trial and error, then I can look for things that only have one possibility remaining, and then remove that or place that value in the board, because that's the only thing that's possible. Do the assignment for that. And then check again somehow. I need to somehow check if any cells have only one possibility at that point. I think I can make it. How can I do it quickly? Check if there's any cells that have one possibility. I can put a Q for it. Once I make an assignment, then the row and column. Once I make an assignment, then I can check the things that are within that row and column and subbox and update those. Do another check whether or not they're only containing one value. This is this intersection check between three sets is kind of, I think, a longish, it's not a constant cost, so I want to try to avoid that as much as possible. So if there's only one possibility, I do the assignment for it. And then I do the update for everything in the row, column, and subbox. A wellness check. Is there a better way? Intersection is 1. I could on the first pass. Okay, on the initial pass where I find the intersection of every row, column, and whatever, I could store that information. And then when I do the actual assignment based on that, if there's only one possibility, assign that value to the board, then I can remove that value from the possibility sets of the things that are within the same row column subbox, and have a queue for that, and add to the queue if there's only one possibility remaining after removal. Okay. Okay, so what's going on here? Let's go ahead and create a board possibility 2D array. This is going to have only possible values for each position based on row, column, subbox constraints. So I think this is going to be it's going to be 2D array, and I guess it's, what do I make it with initially? I guess I make it initially with maybe just zeros. 0 times 9. Does that work? Why am I so bad at making 2D arrays? I don't think 0 times 9 actually works. I think it's maybe, we'll try it. For blank in range 9, and turn, just want a 2D array of zeros 9 by 9. I think this is too many brackets. Okay. I think that's what I want. Yeah. Okay, so for each board possible position, so if it actually has a number, then I think I want to do with that spot. Keep it as 0. I guess I can skip it for now. Sure. And then otherwise, it's going to assign the actual possibilities for that row and column. Okay, 0, 0, 1, 2, 4, 2, 6, 7, 0 for 7, 8, 2 for 6. Okay, so that's fine. Okay, so then what? So then I want to have a queue. So process queue. And I think I'm going to add to the queue every position where it has a single possibility. So if the length of the board possibility of this row column is equal to 1, that means there's only one possible value to assign there. Then I'm going to do process queue, add, or I guess it's append this position. I guess do I need to care about the value? I mean, the value should only be 1. Yeah, this position. And then while there is a process queue, then row column is popped, pop left. I think it's pop left. It's been a long time since I used queues. Pop left. Okay, lowercase. And the board at this position needs to be assigned that value. So let's say the value is the only thing that's left in the set. So value is the board possibility at this row column. That's a set. You can just press pop. And then the board at this row column is equal to the string of that value. I think we can do that. Oops. Okay, yeah. Do string the value, and then you iterate over all the positions. You iterate over everything that's in common with it in the same row and column. Maybe I could do a done set. I could do yeah, okay, so for remove this value from possibilities of neighbors in same row, column, and subbox. Add to queue if only one possibility remains. Okay, so going over this stuff in that row. So for row in range 9, so I guess this means it goes over the row indices of the same column. If the board at this book, let's say K is the row, same column is not assigned. So that means it still has to be, there's still some possibilities there. Actually, let's see. Row, column, process, pop left, value. I guess I should probably check if it's already assigned here. You might be redoing work if it's like there might be multiple things that figure out something is done. If if board at this row column equals, or doesn't equal a blank, then, or does equal a blank, then skip it. No, doesn't equal blank, doesn't equal blank. Because it's already been processed. Okay. So for every row index, if the board at that row index, same column, has a blank in it, does not equal blank, or does equal blank? Yeah, it doesn't have a blank. If it has a blank, then you skip it. Okay, if it has a blank, then skip it. Okay, so if it doesn't have a blank, then remove this possibility from that spot. So from that same column, different row. Okay, so row board possibilities at this spot dot discard this value if the length of the board possibility at this spot is now 1, there's only one thing left, then process queue add append this spot to the things to do. Okay, I think that's right. And then for everything in the row, and then everything in the column, same row, different column, same row, different column, discard. If that spot has only one possibility, add that. I feel like this is kind of inefficient in how I'm processing when I'm doing things. Alright, whatever. And then going over the same sub box. So, oof, that's gonna be rough. The same sub box. So, how's that gonna work? For K in range, say, so for K box in range 9, sub box, same sub box, huh? So the sub box, how do those indices play out? I could literally do the mapping like, so that's K box. If I'm dealing with K box, let's say 3, K box 3 be row 0, column 6, 7, 8, row 1, column 6, 7, 8, row 2, column 6, 7, 8. That's annoying. That's like, ugh, the logic there. For everything, so K box is actually not what I want here. I need to identify what the, well, is it not? No, so I go from board possibility. So I'm looking at the board and positions on the board that match the same subbox. The position on the board to match the same subbox. It's annoying. So if I'm at, let's say, this position, I figure out that I'm dealing with subbox 0, 1, 2, subbox 3, and from knowing that I'm dealing with subbox 3, then I need to iterate over the row column positions of that subbox. The row column positions of that subbox. I could for each position, okay. So if I know what the subbox index is, and box is going to be, the box will be this index. So the offset, so that box, so the first 3 times, I guess I can just do a nested for loop, yeah. Okay. For k row in range. So if this is box 3, then the row is going to be from 0, 1, 2, 3, 4, 5. So it's going to be range 3 something and then 3 more than that. I think it's going to be box divided by 3 times 3. And box divided by 3 times 3 plus 3. So initially it's going to be 0, 3, or 6. And if it's 3, it goes 3, 4, 5, 6, 7, 8. Okay. And then the column, so if this is box 3, I think it's box mod 3 times 3. Is that right? Box mod 3. The remainder. I think that's right. Box mod 3 times 3. And then same deal, box mod 3 times 3 plus 3. I think that iterates over the rows and columns of that subbox. And then board possibility at this k row, k column. discard this value. Actually, I need the same if statement. If the board at this k row, k column is blank, is it blank or is it not blank? Continue. Only if it's blank, then continue. If it's not blank, then continue, right? If it's already filled, then skip it. Ooh, that's pretty bad. I missed it before. If it's not equal to a blank, then skip it. Okay. If the length of the word possibility at this k row, k column. This is really redundant, actually, because I'm processing the same stuff as before. Because if it's handling the same row and it finds that the row needs to be processed, it's appending it here, and then it's doing it again here, maybe. I guess maybe I can do queued as a set of things, set of board positions that are in the process. So maybe visited is queued is going to be false times 9 in the range of 9. Okay, so here when I add it, so if this position is queued, already, then skip it. We do need to queue it, or say this is queued now. Append k row, k column. Okay. So if there's a number there already, or if it's already queued, then skip. Otherwise, remove it from the set of values that are possible there. And then if there's only one remaining, okay. Let's see if it does anything here. Print the board. Sweet mother of a baby. Okay. Did I print out anything here? Standard out. So I did print out something. Where was that printout? So to print. That was the only print. I must have printed out something else. Oh. Where's my other print? Yeah, there's no standard out here. So I must have another print here. Has to be another print here. Output. Okay. I'm like, how odd. I saw standard out. See if it actually works. No, it doesn't. Fuck. Okay, so I think maybe my assumption here is probably invalid, that there's actually stuff that is always there to be solved. So I need to do some custom checking. Say print out the row, column, and board possibilities at this row column. Maybe I print out the length of that possibility. Well, actually there's one here. Actually there's several that's one. Interesting. Okay. So let's go ahead and see what's going on here. And then do process, row, column, and value maybe. And then at the end of this, I'll print out the length of the queue. Is it called queue? It's called process. Object is not callable, line 45. Oh, whoops, this print. Test case. Oh, no, I didn't use the test case, yeah. Yeah, well, test case does have things that are down to 1. 4, 5, 3, 2, 8, 7, 6. Interesting. So it solves it up to a certain point. Solves it up to a certain point. And then I guess it needs to be guessing and checking after there. 1, 2. So here could be a 3 or 3 or 5. Same deal here. It could be like a 5 or 3 here. So I think the logic is fine up to where it can't figure it out, and then it needs to guess and check. Three or 5. 3 or 5 here. 3 or 5 here. Okay. Yeah, it's missing this 3 or 5. It's missing this 3 or 5. So it's filling out stuff. It's not filling out enough because it's not actually trying to backtrack, guess and check and backtrack. Okay. Okay. Let's see here. So what's it gonna do here? So if there's nothing left that is guessable, or there's nothing left that is knowable to be assigned, then it needs to randomly pick a value from the possibilities of that cell. Randomly pick a value from the possibilities for the cell, and then try assigning it and somehow reversing those assignments if necessary. So we need to assign here, assign those. Ideally, we'd start with the things that are the smallest impossibilities, the count possibilities, and then expand. So if there's only 2 possibilities, it picks 1, fills out, fills out, fills out. So like it picks this one, makes it, let's say 3, then it makes this one 5. Some point it figures out that that's wrong. Only 7 test cases. If you have assignments where you assign, move on to the next cell, assign, but how do you store how do you store that information? I could have a stack that is like the assignment stack or history stack. And then each time I assign, particularly if I don't know if it's the correct value, I put on the stack, put the next assignment on that stack, and then either the stack goes to completion, or anytime I find an impossibility, then I reverse it. Go pop things off the stack. When I pop things off the stack, then I would put that possibility back onto the cell that it removed it from. Does that work? Put that possibility back in the cell that it was removed from. Okay, so maybe I need to do multiple phases. This thing is like, I don't know if this is the best way to do guess and check, because I don't want to permanently remove stuff from the possible sets at this point, or after this point, because there could be a need for reversal. Everything up to this thing is guaranteed to be correct in terms of if it has some assignment. That assignment is definitely part of the solution. But after this, if I assign a 3 here, I don't really want to remove 3's from everything in the same row and column, because I might need to reverse that. So I assign a 3 there, and then what though? And then I go to that spot and assign a 5 there. Assign anything but a 3 there. Assign anything but a 3 among its possibilities. Interesting. Anything but a 3 among its possibilities. But then in the order of operations, I probably go to the first thing in the same row. That's free, and assign something that's not a 3 to that spot. Yep, I'm pretty close, but also not really. 3, 5, 35, 53. Oh. Yeah. 3, assign a 3 here. Remove 3's from here and here. So would I do that? Technically 3 cannot be here either. So I assign a 3 here. Then maybe I keep a list of all the other things that are changed from it. Seems like a really long possible list. Assign. All right, I think I need to take